Hello, everyone, and welcome back to Geology 106. The time is 2:53, and we are going to get started very shortly at about 3 o'clock. I will post a link for y'all to the PowerPoint slides. Make sure I have the right, copying the correct ones. Okay, there we go. And post that in the chat for you guys. All right, slides there. Let's see. Today is the last day of lecture. Oh my gosh. Quarter went by pretty quickly. Neither here nor there that it did, but excuse me. Just trying to stay hydrated. So, how is everyone doing? Oh yeah, Alicia says it also went by really fast. It started out kind of like slow, but it, as per usual, picked up the pace pretty quick. So, I'm doing okay. I had the opportunity to pick up my car today, so I'm really happy about that after my transmission blew like a month ago, and the dealership has had it like all this time because they've probably only had like, I'm guessing like 4 or 5 people working there in maintenance during COVID. So I think that because I know someone who works at a different dealership and they said, yeah, there's like less than 10 of us working on any given day. So yeah, well, I mean, I don't blame them too much because I've been to this, car dealership several times, and that's not normally the case. It's very much a COVID-19 thing. Normally they have very good customer service, so I can recommend Magic Toyota in Linwood. They're pretty solid over there, except right now. Well, actually, now that they've opened back up a lot more, there was a ton of people there today, so I was really happy about that because it means that more cars are going to get work done. They're going to get their backlog taken care of and be able to start taking in, get cars done sooner and whatnot and keep the economy going. Yay. I like that I have lived in a thriving economy most of my life. So it's very convenient. Yeah. Toyotas are fabulous. I accidentally killed my first Toyota, my first car. I didn't realize that the oil in my Camry started leaking, and the oil ran out, and I kept driving my car because the oil light didn't come on. So make sure you regularly get your oil checked, unlike I used to, but do not currently any longer. My oil gets changed now. But yeah, I currently have a RAV4, like an older RAV4, like what year is mine? Like a 2005 or something. And I really love it, but it's I don't recommend one from that era because I have heard that Toyotas in that era can have, or RAV4s, not just Toyotas in general, but RAV4s from like the 2000 to 2005 era can have a problem with their CM, their computer, I think it's called their computer module, that makes your transmission go bad. But the mechanics don't believe that happened to my car. Hopefully they're being truthful and didn't just replace the transmission. But yeah, in any case, I really like them though. But just out of curiosity too, in addition to how everyone's doing, I'm curious to know how everyone's doing today and whatnot. I'm also curious too, what were people's favorite topics that we covered this quarter? And what was your least favorite topic? Like, don't do this topic in the future. Like, and why exactly. I'll type that in the comments. So there's a crow perched outside my window. Rocks and tectonics are some of my favorites too. Although I also am very passionate about hazards as well, in case you couldn't tell. In case that was difficult to find out, I'm also very passionate about geological hazards and learning more about them and getting the public prepared to deal with them, because we're often not as prepared as we think. I also just bought too on Amazon for myself, because I realized like I don't have a hand crank radio / something I can charge my phone with / general emergency thing. So I got this multi-tool for like $20 off Amazon. That's a hand crank flashlight, radio, phone charger. It's got a USB plug on it, and it's solar powered too, in addition to being hand cranked. And I believe you can also charge, that there are batteries in it that you can charge. And I read reviews on this thing, and it lasted people for like 2 days during hurricanes and stuff. I'm like, it sounds like a great thing to have in an emergency kit. And they didn't even have to crank it or like put it out in the sun. They just charged it prior to like the hurricanes, and it lasts on that charge for like 2 days. Let's see, least favorite rock classification. Rock classification, it especially gets hairy online. I was very unsure how to do that this quarter. So, like all other classes this quarter taught by people who have never taught online before this quarter, it was a great experiment to see how I wanted to try and do that. It is definitely difficult, and I do prefer doing that kind of stuff in person. I also couldn't get you guys like anonymous rock kits or anything like that, so that was kind of difficult. But yeah, so see, it's 3:01. We have 3 people with us, so let me just say a couple things. Number one, today's lecture is going to be really short. Awesome. It's kind of nice just having this last chapter of the quarter be like half a chapter, and a fairly like simple one that doesn't have like a ton going on in it. It's kind of almost like a reprieve, like a respite. I like that at the end of the quarter. And I think other people do too. So then also I noticed that on the focus questions that some people have like copy and pasted answers from various websites or like whatnot. That does count as plagiarism. And the only instruction on the assignment for focus questions is to write things in your own words. So you guys will notice as I'm going through those and grading them that I can't give you credit for plagiarized work. So like those questions that you plagiarized on won't get any credit, or that you copy and pasted from websites. And it kills me to do that, actually. I really hate doing that because I'm always rooting for you guys, and I'm always like wanting to be in your corner, and I want to guide you guys to being like as successful as possible and not wasting your money and learning as much as you can in this class. But I assure you, I'm usually much harsher. I'm feeling quite soft this quarter. I normally give people just 0 credit for the entire assignment because I am kind of tough like that. So I'm sorry that you guys are probably going to see losing a few points here and there on those focus questions, but I definitely can't. It's not something that I can give credit for when that's like the only instruction on the assignment. So But it doesn't look like people did that for every single question on all of their stuff, just for some of the tougher ones. And so looks like everyone's going to still be getting most credit, which I'm happy about because, like I said, I really want you guys to succeed, and I want you guys to be able to learn the most that you can from this class. But let's see, other stuff. Oh, yes. Monday, there will be no lecture this coming Monday. It's just a study day. What I'm going to do, though, is I'm going to actually host a study hour from 3 to 4, where I'm just going to be here grading. I'm not going to be lecturing. It's going to be like a Zoom thing. It's not going to be a YouTube live lecture. So I'll post a Zoom invite link and password on the Canvas website, and I'll just be here studying. So if you guys want to also study during that time, you can just hop on to the Zoom call, and you don't even have to have your camera on. You can literally just mute your camera, and then as you're studying, if you're like, oh, hey, I have some questions, you can just like turn on your camera and be like, hey, Caitlin, help me with this. Or this is something I didn't quite get. That's perfectly fine. So I'm hoping to get some grading done so that maybe in that time people can look over past assignments and ask questions, or look over past exams and ask questions about that. So it's very much, though, just a study time. It's not really a social hour or just talking about general interesting things. It will really just be, we're here in a study room studying together. So yeah, if that sounds good to you guys, though, there will be a link. So yeah, does anyone have any questions about that, though, about what I'm kind of envisioning? I had another instructor tell me that they've been doing this like all quarter, and I was like, that's genius. I wish I had heard you say that sooner, because I probably would have done that. But yeah, I went hiking with them last weekend. That was glorious. Went up to Denny Creek, went rock hunting. That was wonderful too. So anyways, though, it doesn't look like there's any questions. Let's see, no questions. Okay, so let's go ahead then and just dive into lecture. And we're going to start talking about wind transportation in deserts. Awesome. It's so cute how on like Google, like on shared drives and things, or shared stuff, you can see like different icons at the top for like the PowerPoints. There's like an elephant and like some other kind of animal. It's so cute. Sometimes they're dinosaurs, and I don't know if you guys set that or if Google chooses them at random. Okay, which slide number were we on? Something like 18, I think. We were on 17. We were on slide 17. So we're going to pick up there. And what we were talking about previously is we've talked about the different kinds of deserts already. We've talked about what defines just a desert, period, and then what different kinds of deserts there are. And we have also talked about water as an erosional agent in deserts, in that water does the most damage when it is in a desert. So now we're going to talk about wind transportation and kind of wind erosion, not really, but we are going to talk about what happens as a result of wind erosion, just a few things. So before we start talking about what erosional landscapes, or a few erosional landscapes that get left behind when wind erodes and transports away sediment, we're first going to talk about how wind does the actual transporting. I will also just say, in case you're wondering, I don't have a slide for this, but how does wind erode? It erodes by, crashing, like carrying and transporting other sand grains and then hitting other stuff. And that's how it erodes. It erodes by abrading when it is carrying other stuff and it's already transporting some loose material. So sandblasting is exactly what we're talking about with erosion. But let's talk about transportation, because it's actually usually the first thing that wind does, and then it starts eroding. It picks up what's already been eroded. So chatting about that, first bullet point that will get filled in for you guys on that slide, gotta go over my PowerPoint too, is that moving air can pick up and transport loose material. I hope that wasn't shocking because I kind of have already just said that. So it picks up and moves loose material. And it is in some ways similar to a river, and in some ways it is different from a river. So the first sub-bullet point is similar to a river in that, and then there's a sub-bullet point. And then the next one is going to be that they are different from a river in that, and then there's 2 bullet points below there demonstrating how they are similar to wind transportation is very similar, but sometimes different than water transportation. So they are similar to a river in that, the bullet point below that, it transports particles via suspension and saltation, as well as bed load. Well, saltation is really a form of bed load. So let's see, we can ignore this for now. I don't want to waste time erasing it. Basically, remember we talked about with like rivers and stuff. We're not talking about the stuff above the black line. That's for rain shadow deserts. So basically, suspension is when you have a particle that is traveling. This is the ground here. It's when you have a particle that can travel through wind or water in suspension, meaning that it has no contact with the ground during its transportation. This is suspension, right? So then bed load is going to be into kind of, there's 3 sub ways that bed load is transported, and that is like saltating, where it kind of like will skip up in the air and then land down, and it will get pushed back up into the air or water and then settle back down, and it'll keep doing that, right? So another way that bed load gets transported is by rolling. So it'll literally just roll along the bottom, and it never actually loses contact with the bottom. But anytime that it is in contact with the bottom, we call this bed load. Then the other way that a particle can get transported as bed load is that it can just slide along. And it doesn't necessarily roll and tumble over, but it just like keeps sliding along, just being pushed. So water does this, wind does this. Water, though, as you guys might recall, has the additional thing where it's like it can transport a dissolved load, because some things are soluble in water, can dissolve into the water, and the water can carry it as a dissolved solution, and then it can be deposited as a solid later if the water like evaporates off or something. Wind doesn't do that, though. We just have these 2 categories of suspended load and bed load. So, got a couple whiteboards here. I'm trying to juggle. All right. So filling in some more of those blanks for you in different from a river, we just basically said that, which is that it is, well, actually, I don't have a bullet point for this, but I did just tell you that there's no dissolved load as there is with a river. So it is different in that there's no dissolved load. But the 2 bullet points that I have there stating how it is also different from a river is that wind is less capable of transporting coarse material. So kind of going back to this whiteboard here, if I had, so I've got some particles here, these ones. If I had just like one really big particle, a very coarse particle is what that means. The wind would have to be pretty strong in order to move it. And some things just are so big that, winds don't typically reach what would be needed in order to transport the coarse material. So the water, however, though, doesn't need to have as much energy, I guess, as to transport things, or water is just more suited for transporting coarse material than wind is. And then also, second important difference between a river and wind transportation is that wind is not confined to a channel. Wind is just however, the large the area is that is experiencing wind. So you can transport a lot of, fine material. So then the last bullet point there, large bullet point, says that it's a relatively insignificant erosional agent. Because we see wind doing a lot of the transporting. And yes, over a great amount of time, it is quite capable of great feats of erosion. But that takes a long time. It takes a really long time. Water in a desert, it's going to do damage like that, just super quickly. So it is a better erosional agent because it doesn't need a lot of time to do a lot of damage, whereas wind is not as good of an erosional agent. It will take it forever to get the job done. But it likes to transport things and blow stuff around willy-nilly. So then let's go ahead and move on to slide 18 and talk about wind transportation, specifically talking about breaking down bed load more as well as suspension. So let me see what blanks I left in for you guys. All right, so let's fill in that first sub-bullet point there for bed load, which is how is bed load transported? And I have a diagram here for you guys on these two at the bottom. Typically rolling, as I said before, or saltation, which is like that kind of skipping type of motion. So rolling or saltation, in parentheses, skipping, of larger particles along the ground. So not so much sliding, although we have seen that in the desert. There's literally these weird rocks in I think it's Death Valley, that have these tracks behind them, and the rock's just sitting there, and people are like, what's going on? I don't think it's actually wind that blows them along, but I think it's actually some other type of maybe a water transportation agent or something. I don't remember, but it was a big mystery for a long time. So what size of material is typically found being transported as bed load? Typically, it's sand grains. So we have in geology all of these different classifications for coarse particles and fine particles. Coarse particles are things like cobbles, then there's gravel, and then there would be you can break that down into coarse gravel and fine gravel, and then coarse sand, fine sand, and then silt and clay. So basically, you find being transported as in contact with ground is typically stuff that is sand-sized particle. And typical beach sand grains is about what we're referring to when we say sand-sized particles. In suspension, let's talk about, fill in some bullet points there. So only the smallest particles are carried in the wind. So that means we're talking about silt, very fine silt or clay-sized particles. And you can see that in the diagram too, how the dots that they've drawn in the air by suspension, being carried by suspension, are smaller than those that are on the ground or in contact with the ground. So first bullet point there is smallest particles carried in wind. And then let's see, did I miss something in the chat? No, very fine, I assume. Yeah, so like when I say silt, I mean stuff that feels like, and clay, I mean stuff that feels like powder. It's so fine. Because sand is kind of grainy, right? And kind of gritty. And that's because the particles are large enough for you to feel that. Versus if it is like silt or clay, when you like rub it against your fingers, it feels more like a powder. And how can you tell the difference between silt and clay? Well, what geologists have done in history when they're out in the field and don't have like sand sifters and things like that, they'll literally like put a little bit in between their teeth and their tongue and rub it against their teeth. And does it have a gritty feeling? Then it's silt. If it doesn't have a gritty feeling and it's just smooth as clay. So we are talking pretty fine stuff. So then the sub bullet point there is that this includes specifically dust, silt, and something I mentioned. Yeah, field science. Great. Have I done this? Yes. So it's dust, silt, say clay size, because clay is not just a thing, it's also like a size classification, as well as something we call, hold on, make sure I'm spelling it right, loess. Yes, I did spell it right. It just looks different because it's so small. I spelled loess in the chat for you. It's LOESS. And we are going to talk a lot about loess today. And then the third bullet point there under suspension is I just have the word deflation. So deflation is something that happens as a result of transportation of sediment, most particularly just suspension. It's something that happens to a landscape when all of these dust, silt, and loess-sized particles are transported away from an area. And then what happens there? So, and loess, we'll also define that term better for you just on the next slide or in a couple slides, in a few slides. So hang on to that word loess because it's not exactly a size classification. It is defined by something other than size. But silt and dust are size classifications. So let's talk about that word deflation though. Let's define it on the next slide for you. We actually have a beautiful photograph below that looks like it might be the Red Sea. Yeah, that looks like the Red Sea breaking off into like the Dead Sea, and I don't remember what the other sea's name is, but what you guys see below there is this cloud of material being transported from Africa over to the Arabian Peninsula. There's just this cloud of fine material traveling over that quite large sea there. That, my friends, is deflation in action. So let's see what blanks I left there for you guys. So wind, the first sub-bullet point there is wind carries away sediment, which I have abbreviated as SED. SED is an abbreviation for sediment. So wind carries away sediment. And if there is no new sediment that's coming in, so no new sediment, and then comma, desert floor lowers. So what does all of that kind of very curtailed bullet point style jargon mean? What it means is that if I like take all the rocks off my table and I don't put more rocks, there's a lot on my table, and I don't put more back on my table, I'm going to be left with no rocks on my table, right? So in a desert, if the wind carries away all of the fine sediment, and there's no new fine sediment coming in, or no new sediment at all coming in, the ground of the desert is going to lower over time because you removed a bunch of the ground and you threw it into the Red Sea or over onto the Arabian Peninsula, for example. Hopefully that makes sense to you guys. So deflation, again, though, is really exclusive to the size particles of clay, silt, and dust only. And that is the last bullet point there. Clay, silt, and dust only. We don't get to move sand particles this way. Sand particles are just a tad too heavy for this process on a large scale. So moving on to the next slide, we see a picture of a man standing next to a mound of some kind of like desert grass. And he is clearly elevated above, to like his kneecap or so. And we also see in the cartoon diagram onto the right-hand side, there's on the top block, there's some wind going over the desert sand. And then in the bottom, we see that wind actually excavated some of that sand out. So this is the process of deflation indeed. And when that is confined to a small area, we call that a blowout. So if it happens to just like a small portion of the desert floor, we call that a blowout. Because you've lowered the desert floor via deflation in just a small little localized area. So let's phrase that into a nice sub bullet point for you guys. So it is a concentrated, shallow depression, not like sad depression, but like lower elevation depression. Concentrated, shallow depression caused by deflation. So yeah, and it looks like basically like 1.2 meters of material got lifted out of that area that the man is standing in. That's quite a lot of material. So that's like 4.5 feet of stuff that got blown away from there. So let's go ahead and move on to slide 21 and talk about some more stuff that happens as a result of deflation. Deflation is wind erosion. So that's why these slides here are now capitalized or called wind erosion slides. So desert pavement is something else that forms as a result of wind erosion via deflation. So it is a stony veneer or coating, if you don't like the word veneer. So it's a stony coating left behind after deflation removes finer material. And essentially what we're looking at is what's going on in that block diagram below, where there are larger rocks mixed in with all of the sand making up the desert floor, as well as not just sand, but primarily the stuff that's finer than sand. So sand and smaller particles are mixed in with like larger stuff, larger rocks. And the wind comes along and picks up all the really fine stuff and blows it away and off to somewhere else. And we're not getting that new supply of finer particles to replace it. So what happens is that some of those stones start being excavated by the wind. They start being, removing the material around them. And if this process continues to remove even more material and layers, we're going to find more rocks that were buried, right? And then the rocks that were above it are now going to join them. And then this process continues even more layers down, exposing more and more rocks and bringing the rocks that were above it but separated by fine material down because you took away the fine material. And then you're left with a bunch of stones on the top of this desert floor. And it is very interesting, this desert pavement, because it is kind of like hard, and it feels like someone purposefully kind of like put it there almost like, and the example there's a photograph, someone with their foot right on top of some desert pavement. So there you have it, desert pavement. So let's also talk about, on the next slide, wind abrasion. So the other stuff is like wind transporting and then what gets left behind as a result of erosion, transportation. Now we're going to talk about like real erosion, which is just not even the transportation, but just like the beating up of other stuff. So slide 22, wind abrasion. We have these interesting rocks below, and they are shaped very funny. We don't care about the composition of these rocks. We don't care about what the rocks are made out of right now. We're just looking at the shape and the fact that they've been shaped by the wind. So wind abrasion, particles, this is that bullet point there for you, particles carried by wind via bed load. So this is primarily a bed load thing. It doesn't necessarily need to be. So particles carried by wind via bed load or suspension strike against a larger rock and whittle away the rock. And the final product of the rock is called a ventifact. Let me spell that in the chat for you, because it's kind of an odd word. And again, let me double check my spelling because I'm a terrible speller. How do I remember how to spell like so many geology words? I don't even know. Thankfully, a lot of them are phonetic. So ventifact. So what I want you to notice in that bottom left picture is that we have a rock that's got three sides, and it's kind of goes up to like a pyramid shape. Basically what happens, I think, is there a diagram in your book for it? Oh, darn, there isn't. That's okay. Basically, you'll have the wind blowing in one direction, and then winds change directions sometimes. So now you'll have the wind blowing in a different direction, right? And then the wind might change direction again and blow in yet a third direction. That is what has happened to the rock below. Each face of the rock, flat surface on the sides of this kind of pyramid-like rock, have been eroded by wind carrying particles and sandblasting it into this shape as the wind has changed into three primary wind directions. And what you're looking at on the quite larger ventifact that someone is putting a scale bar up to is you can actually see like pockets in the rock where the wind has brought sand and silt, etc., into the pockets and is just like clawing away at it, basically. And sandblasting, there must be, I assume, like weaker areas that somehow are being eroded a little bit faster than just the whole face of the rock. Like maybe there were some holes or something, or I don't know. In any case, it's some pretty wicked looking erosion right there on that rock. So yeah, bento facts. I don't have one in my collection. I have a large collection too. Someday. Anyways, let's talk about wind deposits. Some more wind. So we're now talking about, we've been talking about transportation. We just talked about abrasion, like erosion. Now we're going to talk about deposits. So remember, eroding is like the physical breaking down into smaller pieces. Transportation is the moving of something to another area. And then deposition, I should just use this thing. So picking it up is the erosion, breaking it into a smaller chunk that I can pick up. Transportation, and then deposition is when I put the thing down. So let's talk about the deposits. And the first main bullet point that you're going to want to write in there on slide, whoa, I'm behind on your guys' slides, is loess. Oh, I left it in there for you guys. I meant to erase that word. Whatever, it's there. So loess is depositional stuff, right? So let's define, there's a small little dashed line under loess and a blank space where I want you to write this. This is the definition of loess. It is wind-blown silt. So remember how I told you that loess is not a size category or a size classification? Loess is defined by the fact that wind has carried this silt and dropped it. Not water, not humans. It must be silt that was carried by wind. And when it is deposited, we call that a loess deposit. I also didn't necessarily specify what has to generate that silt. So sometimes that silt is in deserts, and sometimes that silt is a result of glaciers pulverizing rocks into like rock flour silt-sized particles, and then that silt or rock flour from a glacier can get wind-blown, transported. So loess isn't actually exclusive to deserts. It happens both as a result of silt created by glaciation or silt that is just already in a desert. We won't talk about how the silt gets in the desert. I don't even know. I actually tried to look that up today and I couldn't even find the answer online. Yay. I'll have to ask some other geologists who are like smarter than me. Who knows? I may end up like nerd sniping them though as a result. So wind-blown silt. Now let's fill in those sub bullet points underneath wind-blown silt. So loess deposits tend to erode as in vertical cliffs. So when this fine silt, wind-blown silt deposit called loess begins to experience erosion, it will go like form these kind of flat cliffs, like what you're looking at there in the photograph below. Another important thing is that loess lacks bedding. People are like, I don't remember what bedding is. I guess I will use this rock. I don't know that this is actually bedding, but it kind of, no, we'll use, hold on. Said I had a lot of rocks. We're going to try this one, and then if we're probably also going to try this one. So what is bedding? Do you guys see these lines in this rock going up? This is a sandstone. It feels very sandy. Picked this guy up in like Utah or Arizona or somewhere back when you guys were probably still in elementary school. So this is bedding here. We can see that this layer was deposited, then another layer was deposited, then another layer, and it built up. And you can actually see these are called bedding planes. That line is a bedding plane. And we see bedding as a result. You guys might have in your rock kit your sandstone. It's either going to look like this without bedding, or you may have been blessed with a sample that does have bedding in it, where you can see different bedding planes separating different deposits that were laid down before it was turned to stone. So loess, however, does not show bedding. So it just looks like a large cliff of powder. So let's fill in that last point there, which is that deserts and glacial deposits of stratified drift are the primary source of silt. So I don't know that that means that that the silt in deserts is from glaciers, but however, deserts do have a lot of silt in them, and that could be just as a product of the erosion of the sand particles, breaking them down even farther. So deserts contain a lot of loess, and then glaciers, the stratified drift that's deposits out in front of the glacier, has a lot of that fine particle in it. So those are the primary sources of silt. I'm not sure why the curriculum says stratified drift. I really think that pretty much just any till is probably going to contain a significant amount of silt within it, possibly. So glacial deposits and deserts contain a lot of silt. And so when you come across a large thing of silt, you think, oh, there must be a desert nearby, or, oh, there must have been glacial action that took place nearby. And we saved less for this chapter because glaciers was too long. So let's look at slide 24 there and talk even more about loess. So loess accumulates at the edges of deserts. So we don't have vast loess deposits where you just have a thick accumulation of transported wind transported silt-sized particles. You don't have thick deposits of that in deserts. You do find them, though, on the margins of the desert. So loess accumulates at the edges of deserts. Let's, in that third sub-bullet point, talk about why it actually accumulates there and why it sticks around there and it stays there along the margins. It does that because there, comma, I don't know why there's a comma there, but there, I'm not as good at English, there, grass and the roots of other plants, so grass as well as roots of other plants, trap the silt or dust and hold it to the ground. Basically, there's actual vegetation around the deserts that will trap the silt-sized, dust-sized particles with either their actual like grass and leaves, etc., or with their own roots if they start growing in a spot where a bunch of that stuff was laid down, and it's going to hang on to whatever its roots are hanging on to, right? So the third bullet point there is that this develops into very fertile soil. So this soil, the loess, is actually full of nutrients that are really awesome for growing plants. And that's why like a lot of the, I think that a lot of the Midwest and where we grow a lot of stuff for food is actually grown on loess deposits from glaciers. However, in China, I'm not sure if that's the Gobi Desert or what that is depicted there. My geography is not good enough. So the loess is there. I think it's like on the map, it's depicted as like orange. And I think that everything like to the north west of that is probably the desert. But anyways, they have extraordinarily significant, thick deposits of loess there that are quite noteworthy because they are gigantic. And you can see in the other photograph there that they have 2 pictures of loess where they've got one where they haven't really planted a lot of stuff, or it must be like in between harvesting seasons. I don't know what's going on in that other picture. But then you see a lot of growth of vegetation in the next picture because that ground, that loess, is very fertile. So let's go ahead and check and talk about how sand dunes accumulate. Like, how do you build a sand dune? You know, that's what we're about to talk about. So we're going to draw again on the whiteboard. Because even though I have a picture there, I like to just kind of take it step by step. Now I have to erase this anyways because I want more room on my whiteboard. And let me also make sure that I don't go ahead to the next slide. So we're going to basically break this down further on the next slide, but sand dunes, and here's that first bullet point, they accumulate where their path is obstructed. So if you've got, get some markers there. Also, I should check the YouTube stream and see that I'm in frame. So if you've got the desert ground here, and you've got all of these particles that are being transported by our wind, it's moving all these guys along. If there is something in these particles' way, got a little shrub here, it's going to start catching a bunch of this stuff, right? Voila, we have the birth of a dune. So let's talk about this just a bit more on these. Let's fill in some more bullet points before I go any further though with that. Let me see what bullet points I have. So that first bullet point was that sand dunes accumulate where a path is obstructed. And then the next bullet point there is that most sand dunes, we're all talking about here, most sand dunes have asymmetrical profiles. So they're not nice and, symmetrical like this. They're asymmetrical like that, right? So asymmetry. So even though we talked about the fact that there's several different types of sand dunes, all of the sides of sand dunes, or all of the dunes in general, are asymmetrical. So let's talk a bit more though now about some dune terminology here. Got my sand dune here. So notice that this right here on this side is a very gentle slope. If I were to walk up this, I would be much happier than if I were walking up this side of the sand dune. Is my whiteboard still in frame? Kind of. This side is a much easier walk than trying to walk up this side because this side is steep. And this guy is more of a shallow gradient. This is about what I can handle right now after having been through quarantine and not moving very much. I found that out on the hike this last weekend. So anyways, Most have asymmetrical profiles. So now we're going to, now that I've drawn your attention to this shape, the windward side, which is the first word on that next bullet point. So this is the, I should get another. So this is the windward side. That's all one word, by the way. Windward side is the shallow. It's the side that is gently inclined. The windward side is gently inclined. And you can also remember this because it is the direction from which the wind comes. So then the opposite of this, though, after that, you guys see that it says windward side is gently inclined, and then there's a comma, and then there's more stuff for you to write in there. And what you can write in there is that the leeward side is the steep side. Leeward, leeward side. So some more terminology that you also need to know is that this is called, also in addition to the leeward side, it's also called the slip face. More on why it's called the slip face in just a second. All right. I also want to draw your attentions. I also want to draw your attention to the fact that in this diagram here on the bottom of slide 25, there are some very important things that we are going to talk about in 2 slides from now. Lines on that slide that go like this. They actually draw them a lot better in their slide. They kind of curve them down a bit, which is better and more accurate than what I did. Those are very important because those are bedding planes and we're going to chat about them. So let's move on though to slide 26, and we're continuing the bullet point of the fact that most had asymmetrical profiles. I just couldn't fit everything under most have asymmetrical profiles, all the sub bullet points on the same slide, and include all the pictures I wanted. So let's continue that. On the first sub bullet point there on slide 26, we're going to just chat a little bit more about this. So sand accumulates on the slip face, aka the leeward side, as the wind velocity is reduced just beyond the crest of the dune. This right here, where I drew the star, this is the crest of the dune. So sand accumulates here. We put our new sand particles from the wind here. Why? Because the wind lost energy once it crossed that crest. It suddenly couldn't, it just dropped a bunch of stuff down that slip face, right? All right, here where I've drawn these black dots. That's going to be important in a second. Before I get to why this is important here, we're going to fill in one more bullet point about dunes. And that's the fact, which is the next bullet point on there, that dunes migrate slowly in the windward direction. So basically this dune, in about however much time, is going to be over here. It's going to be further towards the direction that the wind is blowing to, not where it's coming from, but it keeps pushing the dune further and further and further. So it migrates in the direction that the wind is pushing, because the dune is pushing it forward. And it's doing that particle by particle at a time, which is why they move slowly. So here on this slide 26, we can see a nice diagram, cartoon diagram there, showing how a dune was built around, say, a small rock on the desert floor, which served as an obstacle and collected and trapped wind on the windward side of the rock. Because the wind, as it's blowing, it just traps a bunch of the bed load right there. And then we can see that as the wind continues, more and more sand is going to continue to accumulate until we have formed a dune, right? So let's go ahead and talk about our last slide of the entire quarter, which is, yeah, it's an accomplishment, guys. We made it. So sand, this is more on sand dunes. So these inclined layers, as it were, right? In these inclined layers, oops, sorry, hold on a sec. Need to. In the windward direction are called, these have a name, it's called cross bedding. And it happens because of what I drew here. This deposit of sand here. Sometimes sand comes in different colors. And that can allow us to see cross bedding. Also, sometimes they're just different sizes, etc., that allow us to see these bedding planes. So you can tell by looking at a solidified rock face that is cross-bedded. You can tell which way is up, number one. We won't talk about that. Maybe we will. You can tell which direction the wind or water, because this happens with water too, was moving. So if I've got a bunch of layers that are slanted this way, diagonal in this direction, the tips of them kind of point back towards where the wind was coming from, right? Is that the best way to say it? Yeah. So again, recap on that bullet point there is inclined layers in the windward direction are called, I should write that here for you guys. And it is 2 words. I had to double check there for a second. Just because I can't spell doesn't mean I don't know what I'm talking about, guys. I promise. Cross-bedding. So, yeah, I will show you an example. I have one rock. I have 2. I don't know where the other one is. And even still, it's really subtle and it might not be able to be picked up by the camera. But I have a sample right here that actually exhibits cross-bedding. Hold on a sec. Make sure I don't get markers everywhere. Let's put the caps back on those. Let's see if this will show up. Do you guys see these inclined layers here? Let me know in the chat if you guys can see that. I think you can. It looks shown up fairly well on my computer. You can see some more of these layers here. The back isn't very pretty because it's dirty. So I'll actually also let you guys know I'm holding this rock upside down. This is the proper way to hold this rock. Because what happens is that the top of the dune will get eroded away. Like if wind gets really in a certain way, it will just kind of plane off the top, or water will plane off the top of the crossbed that it has laid down. And then it'll start depositing stuff on top of that. I'm guessing that this is actually like a water deposit. However, it is very extraordinarily difficult to tell the difference between when you go up to an outcrop that's got cross bedding. It's very difficult to tell whether that was caused by water running through an area and moving a ripple, or if it was a sand dune that became buried and solidified into rock. I don't even know how you do it, actually. I've never had that explained to me, how someone can even tell the difference. No idea. I'm just guessing based on where I found this. I don't remember where I found this anymore. That's a shame. So this is cross bedding. If I hold this rock properly, I can tell that the water or wind was going this direction because of the way that the layers are inclined, right? Got the layers pointing this way. It's pointing to the direction the wind came from and pointing down towards the direction that it's going. So there you have it, cross bedding. And they stick out like sore thumbs in like Utah and Arizona type Midwest areas. There's tons of cross bedding down there. And then you'll look at this weird rock that's like going this way and then this way and then this way and that way. And you'll be like, oh, look, cross bedding. So, but yeah, in any case, there you have it. I guess that is the end of the quarter in terms of material that we are learning. And then final is in a week from today, starting at 3 o'clock. I do not know how long the final will be. Sorry. Don't know how long it's going to be. I do not know what the time limit is going to be or how many questions there are. Because when I write my exams, I really do write them in the few days beforehand so that I can make sure that I covered the stuff that I told you about or that I told you to cover in the chapter. And I also do that because I really do tailor them to each class and each time that I teach it. So I remake them because it's honestly in your best interest that I don't just reuse the same exam for 10 years, even when the book changes. So yeah, I actually can't do live chat today. I do apologize. I have an engineering meeting that started a half hour ago that is still going on right now. So I'm going to hop on for the last half hour of that engineering meeting. So I do apologize. However, there will be the study hour. Again, it's not really like a social hour for like chatting. It's really just for like, for all of us to be working and being productive. And in our studying, for me, we'll be grading. And then, as questions about the stuff that you're studying arises, like, hey, I'm not sure how this works. Or, Caitlin, can you tell me about this? Then we'll talk about it. So, yeah, other than that, that's going to be on Monday at 3 to 4. So have a great weekend. And I'm hoping to get tons of grading done this weekend because I'm so far behind. Sorry, guys. Grading online is so different than grading in person. I can't do the method I normally do for grading. It's awful. I normally grade things anonymously, but that's impossible in Canvas too. Anyways, enough about that. There's so many excuses I could throw your way, but I shouldn't be one for excuses. I don't like excuses though. In any case, I apologize for being behind on grading, and I will try to get as much done this weekend as possible after helping a friend move for a couple hours. That's just the kind of people that we are in this household. We help people move when they need a hand. So anyways, yeah, have a great weekend. And I hope to see some of you guys maybe for the study session on Monday. Email me if you have questions, if you want to meet some other time besides Monday at 3. In your email, throw out a suggestion of what time you want to meet. I've noticed that that's been difficult this quarter. Like I get an email, or at least since we started going online, I get like an email of like, hey, can you meet? But I won't necessarily catch the email until like that evening. And I'm like, oh no, I have no idea when they will be able to meet tomorrow. So just throw out some times in there of like, what about this time on this day or this time and then I can get back to you. So yeah, anyways, take care. Have a wonderful weekend, and bye guys.